subscribers, welcome back to another episode of Science with Surback. Today what we're going to be doing is some extra Henry's Law practice. So I'm going to do one problem and then I'm going to expect you to do the remaining problems. Alright, so we start out here with the formula. I'm going to squeeze this into the top margin here. And so as a reminder, the initial solubility, which we're going to call S1, divided by the initial pressure, we're going to call P1, is equal to the final solubility divided by the final pressure. Now remember, solubility is in units of grams per liter. It can't just be in grams, it can't just be in liters. So what we're going to do here for problem 1 is this. I'm going to read the problem and then we're going to go over and identify the variables of what we know and don't know. So problem number 1 states, calculate the mass of gas dissolved at calculate the mass of gas dissolved at 150 kilopascals if 0.35 grams of the gas dissolves in 2 liters of water at 30 kilopascals. Okay, so what we're going to do first is we're just going to list out the variables and go through them. So our initial solubility, or S1, is not directly given to us. It says, hey, we have 0.35 grams of this particular gas that is dissolved in 2 liters. So again, we have 0.35 grams of that gas, and we need to divide that by 2 because that is the amount of liters that we have. So our S1 is going to become 0.35 divided by 2, which gives us a value of 0.175 grams per liter. Now, our initial pressure, or our P1 is 30 kilopascals. Again, it says this 0.35 grams in 2 liters was at a pressure of 30 kilopascals. So that becomes our P1. Now, our S2, our final solubility, is something that we have to go find because it says calculate the mass or that solubility. So our S2 is going to be our question mark. And then our final pressure, we crank the pressure up to 150 kilopascals. So we have 150.0 kPa. So now we have all of the values that we need to find our S2. So what we do here is we plug these values back in. Our S1 was 0.175 gram per liter divided by our P1, which was 30 kPa, is equal to that solubility, that final solubility, all over the final pressure, which was 150 kPa. And there are numerous ways to solve algebraically for this. What I'm going to do is I'm going to cross multiply. So I'm going to take 150 times 0.175. So what I'm going to get, and I'm going to use all my space here, I'm going to get 0.175 grams per liter times 150 kPa equals, I'm going to cross multiply my other diagonals, 30 kPa times our S2. And I'm going to put S2 out in front times 30 kPa. Again, we want to get S2 by itself. So S2 is attached to that 30 kPa via multiplication. So what we have to do is this. We have to get rid of it by dividing each side by 30 kPa. Again, what you do to one side, you have to do to another. So we're going to divide each side by 30 kPa. And when we do this, we need to put a set of parentheses on that top product or that top multiplication business. So in my calculator, I'm going to put a parenthesis, 0.175 times 150.0, close my parentheses, divide it by 30.0, and press enter. So my second solubility here, or my S2, is 0.875 grams per liter. So I'm going to put S2 equals 0.875 grams per liter. But wait, we have to be careful because the problem said, hey, calculate the mass of gas dissolved. Well, this is per liter. We have 2 liters of our solution. So what we need to do, the reason that we need to do this is because we have 2 liters. So we need to multiply this by 2. So I still have it stuck in my calculator. What I'm going to do is I'm going to multiply this by 2, and this would get us I don't know if you saw that on the calculator, 1.75 grams of gas dissolved. And again, S2 equals 0.875 grams per liter. We multiplied it by 2 because that's how many liters we have. So that means 1.75 grams of gas is dissolved. Okay, so now I want you to use the same formula in the remaining problems here. I do want you to notice on a few of these, you need to find the solubility. So you need to divide that grams divided by the liters you have. And you also need to pay attention to the question that it asks. If it asks for the mass, make sure you multiply the final value or the final solubility by the appropriate number of liters. All right, I hope you have enjoyed this particular episode. And as always, if you haven't done so already, make sure you subscribe.